Welcome, beautiful peoples, in dark core. Here is the entire text you provided rewritten as a continuous paragraph without omitting any words. Man evolved in the universe relatively recently in comparison to the age of our planet Earth. Throughout its existence, our Earth has experienced a great number of natural disasters which noticeably affected the way it looks today. However, it is the inflow of meteorites that can be singled out as a cause of the most dramatic changes, and the number of these bodies that have hit the planet's surface is quite uncountable. Imagine finding out that a giant asteroid was on a collision course with our planet. What consequences do you think this would lead to? And what about the place where the largest ever meteorite struck the Earth? What does this place look like today? The first in outer space. First of all, let's dwell upon the terms used in science to refer to such astronomical bodies. The term asteroid was coined at the beginning of the 19th century. It was used to refer to star-like dots that can be seen through a telescope, and which differed from planets by their appearance of disks. That was a reason why asteroids used to be classified in the same category as small planets up until 2006, the defining parameter being their diameter that had to measure not less than 30 meters. Celestial objects falling short of this size are called meteoroids. Astronomical bodies that eventually burn up in our atmosphere fall into the category of meteors, and those bodies that make it to the surface of our Earth or any other large object in space are referred to as meteorites. On impact, most of them have a mass ranging from several grams to dozens of tons. On average, the overall mass of meteorites falling on the surface of our planet every year may reach as much as approximately 2,000 tons. Generally, meteorites enter the Earth's atmosphere at speeds of approximately 50 kilometers per second. As a result of such rapid movement, we are able to observe heated fireballs of intense brightness. On reaching the surface of a planet, a meteorite would have experienced heating and ablation on its way, and its mass would have become smaller than what it was on atmospheric entry. As for tiny celestial bodies with no mass to speak of, they burn up almost completely after experiencing speeds of over 25 kilometers per second. When a meteorite makes it through the Earth's atmosphere, it loses its full velocity as it decelerates due to air drag. This, in its turn, subsequently changes the trajectory of the fall. For example, if the original trajectory of the meteorite's fall is horizontal, as a result of deceleration on its way, it may drop toward the surface of a planet almost vertically. Simultaneously, the fireball gets dimmer during the process, and the object itself considerably cools down. But if an astronomical body manages to reach the surface of the Earth in the end, it collides with it, and this phenomenon is known as an impact event. As a rule, a crater is usually formed upon impact, and there is a risk of a fire, an earthquake, or a tsunami in the area. An impact event is able to trigger some really disastrous processes. Some theories have it that it is meteorites' inflow that is to blame for major extinction events of species in the past. When an astronomical object of this kind collides with the surface of our planet at high velocity, a staggering amount of energy is released, accompanied by powerful explosion processes, resulting in the formation of a crater with a diameter by far larger than that of the meteorite itself. For example, the well-known crater in Arizona with a diameter of 1.2 kilometers was formed about 50,000 years ago when the surface was hit by a 50-meter astronomical body with a mass of approximately 300,000 tons. The force of the explosion upon impact was comparable to the explosion of 8,000 atomic bombs of the kind dropped on Hiroshima. Following an impact event, there may appear rock formations as a result of a process known as shock metamorphism, as some mineral deposits like copper and nickel deposits in the Sudbury Basin have come to be thanks to this phenomenon. Meteorite craters may measure up to 500 kilometers. There may even be settlements within their borders. For example, the Vredefort Crater, located in South Africa, was dubbed after the town inside it, with the crater's diameter reaching 300 kilometers. Just to compare, it is about 1.3 of the Chicxulub crater or the Sudbury Basin. The object was formed over 2 billion years ago as a result of the Earth getting hit by an asteroid with a diameter measuring approximately 10 kilometers. Vredefort is considered to hold the second place among the most ancient craters on Earth and is beaten only by Swavjavi, whose age is about 2.4 billion years and which is thus several hundred million years older. The object is also the largest crater apart from the unexplored Wilkes Land crater with a diameter of approximately 500 kilometers, covered by an ice shield in Antarctica. The Wilkes Land crater is likely to have been formed on a collision with an asteroid whose diameter measured about 60 kilometers. At first, Scientists were unable to determine the date of its formation, but recent studies reveal that the crater's age is approximately 250 million years. It is highly likely that this impact event caused a mass extinction in the Permian period. It would have been dramatic to such a point that 96% of all ocean species and 73% of all land species died out as a result of this collision. However, to date, this version has not been confirmed, as exploration of the crater is difficult due to its location. It is worth mentioning that not all meteorites leave giant craters upon impact, and many astronomical bodies hit our Earth with by far less force. The Hobart meteorite, for instance, didn't leave any large crater, but it is this object that is the largest astronomical body ever to have been found on the surface of our planet. This object is the biggest piece of iron of natural origin on Earth. As for its mass, it is estimated at 66 tons. The meteorite's volume is 9 cubic meters, and its diameter measures about 3 meters. Hobart hit the Earth approximately 80,000 years ago, although its discovery was made only as late as in 1920 near the town of Grootfontein, which is situated in the Republic of Namibia in Africa. It was a chance discovery, as neither a crater nor any other signs of the fall were to be seen that would be indicative of the impact. A possible reason for this could have been Hobart's deceleration in the atmosphere. The object's surface is smooth and flat, which is untypical of most meteorites. As for its chemical composition, Hobart is a dense metal object with 84% of iron, 16% of nickel, and also traces of cobalt. Even though the meteorite has never been weighed, its original mass is estimated to have been approximately 90 tons. Interestingly, the Hobart meteorite didn't cause much damage to the planet's surface, which is really stupefying. As a rule, the gravity of consequences depends directly on where such an object falls. For example, the meteorite whose force supposedly caused the extinction of dinosaurs fell in the vicinity of the Yucatan Peninsula, hitting shallow waters in an area where there were gypsum or plaster rock deposits at the time. As a result, large amounts of sulfates were released in the atmosphere, which in its turn led to the prolonged period of global winter. Since the asteroid struck the Earth at an angle of about 60 degrees, a great amount of dust was released into the atmosphere. As for the collision itself, it would have caused a tsunami of about 80 meters. A high-temperature shock wave would have swept across the entire planet's surface, causing wildfires on its way, and particles of dust and soot floating in the air triggered a climate change when direct sun rays rebounded from the dust cloud, not reaching the surface of the planet. This cloud would have persisted for several years. It goes without saying that the chance of a collision of the kind taking place today is infinitely small, as the fall of a large meteorite is a rare occasion. However, man hasn't yet come up with a contingency plan to ensure our safety should a threat of this kind actually materialize. Just to give an example, one of the most dangerous asteroids on collision course with our Earth is 1950 DA, a small near-Earth object with the highest Palermo rating of the potential hazard of impact. The closest approach with the asteroid is going to take place in 2032, and the odds of its hitting the Earth in the year 2880 are estimated at 1 in 300 at the most. In this case, the human race is going to be affected by catastrophic calamities such as a global climate change, with a significant part of the biosphere getting destroyed as a result. The diameter of 1950 DA is 1.3 kilometers, and its mass hasn't been estimated yet. The second most potentially dangerous celestial traveler is considered to be the Bennu asteroid, which is estimated to be just 300,000 kilometers away from our planet. In the year 2135, the date of its possible info fluctuates between the years 2175 and 2199, as this is a period when the Bennu asteroid will approach the Earth relatively closely on 78 occasions. But the odds of it hitting us are 1 in 4,000. The asteroid's average diameter measures over 510 meters, and its mass is estimated to be between 60 and 78 million tons. A collision of an object like that with the Earth is tantamount to the explosion of a bomb of 1,150 megatons in TNT equivalent. Just to compare, the most powerful bomb ever tested by humans on Earth was a Tsar bomber with a power of about 58 megatons in TNT equivalent. It is quite likely that science will soon find a way of changing trajectories of potentially dangerous astronomical objects heading towards us from the infinite depths of outer space. But before it is made possible, we can only hope that no impact event of such devastating force will take place on our Earth for at least the next 1,000 years. Thank you for watching Dark Core.